In the realm of science and enormous privileged insights, the topic of existence ahead of time has had a huge impact. It has blended conversations and intrigued characters for a very long time. This Goliath request tests more than just our methods, it challenges the very foundation of human understanding. Standing at the edge of existence, studying the enormous shadowing, and considering what was there before our universe was imagined, we arrive at the Big Bang, the event that established the beginning of history, space, and what we know. Regardless, there was a moment, sooner rather than later, when this may have been a state of nothingness, a calm before the bombastic gathering began. Assuming this is legitimate, was it truly nothingness? Or perhaps something significantly more profound existed before time itself? As we skip ahead, the science behind this question takes us on a journey beyond imagination. The beginning of the universe, once thought to be a singular event, now puts our understanding to the test. Physicist Brian Cox, known for his contributions to the miracles of the universe, suggests that something shocking might have existed before the Big Bang. He challenges us to rethink our perception of reality. In this exploration, we will dismantle the science, the speculative theories, and the extraordinary secrets that might explain what existed before everything. We'll explore concepts like God's improvement, quantum fluctuations, dark energy, and even the multiverse. The answers we uncover may seem limiting, but they might also open up new understandings of our place in the universe. To delve deeply into a world beyond imagination and science, where shadows continue to linger, we must examine the world prior to the Big Bang and why these theories challenge everything we thought we knew. To appreciate what could have existed before the Big Bang, we first need to understand what the Big Bang actually was. Scientists describe it as an event in which the universe became extraordinarily hot and dense, expanding rapidly and setting off the process that created all matter, energy, and forces. When we look at the night sky, we see evidence of this hot beginning, galaxies moving away from a common point of origin. But why did this occur? Was there ever a time when it wasn't so hot? According to the theory of cosmic inflation, before the Big Bang, the universe was in a state that was cold, empty, and free, essentially like an enormous vacuum. However, this vacuum wasn't completely empty. It contained a massive amount of energy that controlled the expansion of space itself. This rapid expansion, called inflation, settled the stage for everything that followed. At an unbelievable rate, inflation expanded space until it slowed down, transforming energy into matter, particles, and the forces we associate with the Big Bang. But what was the nature of this energy? Why did it suddenly foster the universe? And why did it stop? Scientists believe that this boundless expansion created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching infinitely, with bubbles forming, each bubble representing a separate universe, including our own. This concept, called the inflationary multiverse theory, suggests that there are potentially infinite Big Bangs and an endless number of universes. The idea that our universe is only one of many challenges our understanding of existence itself. It raises profound questions about what else might be out there. The concept of nothingness before the Big Bang is theoretical, not literal. Even if all energy, particles, and radiation were removed from the universe, it would not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and fundamental forces. Even in its most minimal state, space is never truly empty. If we strip away everything, matter, forces, and even radiation, the universe would still generate novel forms of energy. This idea is baffling to scientists, as it suggests that absolute nothingness may be an impossible state. Space itself has inherent properties, rules, and constants that prevent it from being completely empty. Even in a vacuum, quantum fields would still exist, meaning space would never be truly devoid of energy. For instance, the concept of zero-point energy represents the lowest energy state of quantum fields. In this state, particles can still spontaneously appear and disappear, creating a mysterious resonance of activity, even in what should be an empty void. This challenges our traditional notion of emptiness and suggests that something must have existed before the Big Bang. Scientists are still unraveling this mystery. One of the most astounding modern theories is the idea of eternal inflation. If inflation created our universe, it's possible it continues indefinitely. Brian Cox describes an immense multiverse where universes are continuously created through inflation, like sparks lighting new cosmic fires. In this scenario, inflation occurs in various regions, spawning countless additional universes. This process could, in theory, go on forever. This idea of universes giving birth to other universes leads to the fascinating notion of a fractal cosmos, where each new universe might create its own. Every Big Bang could generate a new independent space, untouched by others. For researchers, this theory is both exhilarating and unsettling. It suggests an infinite multiverse with no clear beginning or end. Imagine our universe as just a tiny fragment of an immense, boundless system, constantly evolving and always creating new realms of existence. What if this is the true nature of reality? Perhaps there is no before or after, but rather an eternal cycle of universes forming. Our understanding of nothingness shifts when we consider quantum field theory. According to this theory, the universe isn't merely a collection of matter floating in space, rather, it's an intricate web of energy fields interacting to create everything we observe. These fields resemble intangible oceans, where particles form as waves. Even when these fields are at their lowest energy state, known as the vacuum state, they are still active. Particles can temporarily emerge, gain energy, and vanish again. This leads to the concept of virtual particles, temporary fluctuations that challenge the idea of a true void. Imagine removing everything from the universe, radiation, energy, even matter. Would you be left with absolute nothingness? According to quantum field theory, you wouldn't. Even in a vacuum, quantum fields remain active, sometimes generating fleeting particles. This constant activity suggests that the universe does not adhere to our traditional concept of emptiness. This realization raises an intriguing question. If fields create particles, and particles create matter, might the universe itself have emerged from this void filled with quantum fluctuations? Dark energy, an enigmatic force driving the accelerated expansion of our universe, might provide further clues. Did dark energy exist before the Big Bang? Some theories suggest that dark energy today is a remnant of an energy field that predated our universe's formation. The properties of dark energy hint at a hidden force that may have played a crucial role before the Big Bang. Some scientists propose that dark energy, in a much stronger state, might have driven the inflationary stage, leading to rapid cosmic expansion. If dark energy played a role before the Big Bang, it might have been the catalyst for inflation itself. This suggests that something, perhaps an ancient form of dark energy or another yet undiscovered force, existed before our universe emerged. Could it be that this unknown energy field was responsible for creating multiple universes, each undergoing its own Big Bang? The implications of this idea are staggering. If dark energy existed before the Big Bang, then our universe is not a singular event, but rather part of a vast cosmic cycle, one that has been repeating infinitely. This concept, known as the cyclic universe theory, proposes that the universe undergoes endless cycles of expansion and contraction, with each collapse giving rise to a new Big Bang. If this theory holds, then the universe before ours may not have ended in complete destruction. Instead, it could have transitioned into a state of extreme density, leading to another rebirth. This raises profound questions. Was there ever a true beginning? Or is existence itself an eternal process, with universes constantly being born and reborn? To explore these possibilities, scientists look at cosmic microwave background, CMB, radiation, the faint afterglow of the Big Bang. Some researchers believe that anomalies in the CMB could be hints of a universe that existed before ours. Certain patterns in this radiation might be the remnants of a previous cosmic cycle, providing a glimpse into an era before our own time began. Another theory, known as the conformal cyclic cosmology, CCC, model, suggests that our universe is just one eon in a never-ending sequence of cosmic epochs. According to this idea, at the end of each universe's expansion, matter and energy are transformed in such a way that a new universe can emerge from what remains. If true, then before our universe, there was another, vastly different, yet somehow connected to ours through the deep fabric of space and time. This concept challenges our understanding of what it means for something to begin or end. Yet, there is another possibility. What if time itself did not exist before the Big Bang? Some physicists suggest that time, as we perceive it, was created along with the universe. In this view, asking what happened before the Big Bang is meaningless, as there was no before in a temporal sense. However, quantum mechanics complicates this idea. Certain models of quantum gravity suggest that time may have existed in a different form prior to the Big Bang. Instead of a linear flow, time could have been a more fluid, undefined state, something beyond human comprehension. One of the most speculative but intriguing ideas is that our universe could be a simulation, generated within a larger reality. If this were the case, the before might not refer to a cosmic event at all, but rather to an entirely different level of existence, one where the rules of our physics do not apply. Regardless of which theory is correct, one thing is clear: the mystery of what existed before the Big Bang continues to push the boundaries of science and philosophy. As technology advances, new discoveries in quantum mechanics, cosmology, and dark energy may bring us closer to understanding the origins of everything. Perhaps, one day, we will uncover evidence of a universe before ours, a reality that existed in a form we can scarcely imagine. Until then, we are left to wonder, to question, and to explore the greatest mystery of all: what came before the beginning? If the universe were emptied of all matter and radiation, this force would continue to develop the surface of spacetime. This thought prompts an unsettling question. If dark energy was present before the Big Bang, could it have eventually formed the conditions that led to the birth of our universe? Could dark energy be the quiet architect of inflation or even the true beginning of our universe? In investigating this possibility, we face the potential of dark energy as more than just an influence on our universe. It could be a key that provides access to another theory about the multiverse. An alternative explanation is offered by cyclic cosmology. Instead of viewing the Big Bang as the singular, conclusive beginning, this theory suggests that the universe undergoes immense cycles of birth, death, and renewal. In this model, the Big Bang is not a one-time event but part of an eternal cycle where universes develop, separate, and then recover in another cycle. This theory suggests that our universe could have been restored from the remnants of a previous universe. The process of compression and expansion in a cyclic pattern would mean that there was never an actual beginning, rather, an eternal series of universes emerging, creating, and renewing themselves repeatedly. Cyclic cosmology raises profound questions, as it suggests that time could repeat itself rather than proceed linearly. If this theory is correct, it could mean that before the Big Bang, everything was just another form of the universe, one that collapsed only to give birth to our current universe. For scientists, this theory offers a compelling answer to the question of ultimate origins, proposing that there is no clear beginning. Instead, the universe has always existed in some form, transcending our conventional notions of time and existence. Gravitational waves are another fascinating phenomenon that could shed light on what existed before the Big Bang. Discovered in 2015, these waves are ripples in spacetime caused by extremely massive objects, such as black holes or colliding neutron stars. They can travel vast distances, carrying information about the events that created them. Could gravitational waves provide insights into the birth of the universe? Some physicists propose that gravitational waves originating from before the Big Bang might offer clues about the state of the universe before inflation began. If such waves exist, they could help determine whether the Big Bang was truly the beginning, or if cosmic events occurred before it that we have yet to comprehend. These waves could be remnants of events beyond our usual understanding, hinting at a grander structure beyond the known universe. If these faint signals contain traces of a past universe or an event that preceded the Big Bang, they could reshape our worldview, just as the discovery of the Big Bang itself did. As scientists continue their investigations, the question of what existed before the Big Bang remains open. With current theories pointing toward quantum mechanics, multiverse, and cosmic inflation, we are closer than ever to uncovering the deep mysteries of the universe's origins. Although the complete answer remains elusive, our understanding of what existed before the Big Bang continues to grow with each new discovery. As we explore these theories, we must also consider how they might fit together to form a more comprehensive picture of the true nature of existence itself. Until then, the mystery remains, driving scientific inquiry and pushing us to explore the unknown. As we delve deeper into these mysteries, it becomes clear that our ability to comprehend the universe is constantly evolving. One key area of exploration involves the relationship between time and space itself. Time, as we experience it, may not have existed in the way we understand it before the Big Bang. Some theories propose that time emerged as a dimension from the Big Bang, making it impossible to trace what came before. This idea challenges our fundamental perception of existence, suggesting that the very question of before may not be meaningful in the context of the universe's origins. Furthermore, recent advances in quantum mechanics have sparked new ideas about the nature of reality. One particularly intriguing concept is the idea of a quantum vacuum, a state where, even in the absence of matter, the universe is not truly empty. Instead, it is filled with fluctuating energy fields, which can give rise to forces and particles. Quantum fluctuations may have played a crucial role in the formation of the universe by providing the necessary conditions for the Big Bang. This raises the question, could the universe have emerged from a quantum fluctuation, or was it somehow triggered by these fluctuations? Another fascinating aspect of pre-Big Bang speculation revolves around the concept of cosmic recycling in cyclic cosmology. In this model, the universe undergoes an infinite series of expansions and contractions. After each Big Bang, the universe eventually contracts back into a singularity before expanding once again. This cyclical process suggests that the current state of the universe is merely the latest iteration in an endless series of cosmic births and deaths. Some theorists propose that each cycle leads to slightly different outcomes, meaning that our current universe is shaped by the conditions of the previous cycle. This idea challenges the notion of a single origin, suggesting instead that the universe exists in a constant state of renewal. The possibility of multiple dimensions adds yet another layer of complexity to our understanding of what came before the Big Bang. String theory, for example, suggests the existence of extra dimensions beyond the familiar 3 dimensions of space and 1 dimension of time. These additional dimensions could provide an entirely new framework for understanding the universe's origins. In this model, the Big Bang may have resulted from interactions between higher dimensional spaces, where the collapse of a higher dimensional structure led to the birth of our 3-dimensional universe. If true, this theory would not only offer insight into what existed before the Big Bang but also open up entirely new possibilities for how the universe functions at the most fundamental level. As we approach the limits of current scientific understanding, it is clear that much remains to be discovered. The quest to answer the question of what preceded the Big Bang continues, with scientists pushing the boundaries of knowledge through technological advancements, new theories, and groundbreaking discoveries. One day, we may come closer to unraveling the universe's ultimate beginnings, providing a deeper understanding of the forces that shaped our reality. Until then, these questions will continue to inspire awe and wonder, challenging us to look beyond the familiar and explore the infinite possibilities of existence. The role of extra dimensions and the multiverse. If the Big Bang was not the true beginning, what alternative explanations could exist? One possibility lies in the idea of higher dimensions and the multiverse. String theory suggests that our universe is just one of many, existing within a vast multidimensional space. Some versions of this theory propose that our universe formed when 2 higher dimensional brands collided, triggering the immense energy release that we perceive as the Big Bang. In this scenario, time and space did not emerge from nothing but were instead shaped by interactions between these hidden dimensions. If true, this could mean that countless other universes exist beyond our perception, each with its own physical laws and properties. The implications of this are profound. Our universe may not be unique but just one expression of a much grander cosmic structure. The quantum foam and spontaneous creation. Another perspective suggests that the fabric of reality is not smooth but consists of a constantly shifting quantum foam. According to quantum mechanics, even in empty space, tiny fluctuations constantly occur at the smallest scales. These fluctuations could be responsible for the spontaneous emergence of entire universes. Some physicists propose that the Big Bang was not an isolated event but rather a natural consequence of these quantum fluctuations. If spacetime itself is a dynamic, ever-changing structure, then universes may continuously emerge and dissolve within this quantum landscape. This would mean that the question of a beginning is not relevant. Our universe is simply one of many that arise within this ever-evolving quantum sea. Eternal inflation and the birth of new universes. The theory of cosmic inflation, an extremely rapid expansion of space in the moments after the Big Bang, also suggests the possibility of an eternal process. Some models propose that inflation never completely stops but instead continues indefinitely in certain regions of space. If this is true, then what we perceive as the beginning of our universe was just a local event within a much larger and older cosmic process. This could mean that new universes are constantly forming in different regions of space, each with its own unique physical properties. This concept, known as eternal inflation, aligns with the idea of a multiverse where new pocket universes are born all the time. If this is correct, then our universe is just one bubble within a vast cosmic ocean of other universes, each potentially following different physical laws. Could time itself be an illusion? Another fascinating possibility is that time, as we perceive it, may not be fundamental to reality. Some physicists argue that time is an emergent property rather than an absolute feature of the universe. If time only exists within our universe, then the question of before the Big Bang might not even be meaningful. Instead of viewing the universe as something that began at a specific moment, it could be more accurate to see it as an ongoing process, with no clear starting point. This aligns with some interpretations of quantum mechanics, where cause and effect become blurred at the smallest scales. If time itself emerged from the Big Bang rather than existing before it, then asking what happened before might be similar to asking what is north of the North Pole. It may simply not apply. The search for evidence. While these ideas are exciting, they remain largely speculative. However, scientists continue to search for evidence that might support one of these theories. Gravitational waves, cosmic background radiation, and particle physics experiments may provide insights into what happened before or at the very beginning of our universe. Future advancements in quantum gravity, space telescopes, and particle accelerators may help us uncover hidden clues about the nature of time, space, and existence itself. Until then, the mystery remains one of the most profound and inspiring questions in science.